Good morning again. Today we are gonna delve into a more like civil engineering era in the area of material characterization. So this is the so-called Nakajima experiment, which is an experiment where we test the ability of a material to resist deformation. For this I have built a virtual lab, which you'd want to look at today. So here you see the virtual lab. So this is basically a simple setup which is modeling the the setup of a BUP material characterization testing device. And so you see basically there is the setup. If you zoom out further, you see there are cameras, right? This is usually a GOM system in reality. So, and what we can do here, you see already the ground and a punch. This punch will move upwards and form our sample. What we're gonna now look at is this menu, right? So what we can do here, there are already some parameters preset. We can load certain meshes of deformed samples, which we will see now. And there you see a deformed, basically Nakajima blade. These blades are DIN normed, but you see the idea. And what we have applied here is basically a speckled texture. What we can use this virtual lab to generate synthetic virtual or simulated images of this blender, of this setup, right? So if you zoom out a little bit, you see that's where our cameras are gonna sit, or the direction from which they're gonna take the images. So we can just click render, and then we see on the right panel there are two images. Basically, these are the images which these cameras would see if basically they would take images. Of course, we can change a lot of parameters, right? So let's move one of the two cameras closer to our sample. And now it can click render again. And as you see, now, of course, we are closer to the sample. But we can also change other parameters. For example, the angle to which cameras are rotated, by also the field of view. So let's suppose you have a very wide angle camera, so we have 60-degree field of view instead of 30. Let's then look how our image is going to change. So we have now confirmed, and we are now going to render to create an images. You see the two images now are much more right angle images, so they look different. So I think that gives you an idea of how this entire thing is going to look like. Just for fun, we can move this out much further. Let's say 1,000. Or let's say, you know what, we're going to take 2,000. And we are going to also move out 2,000 from the other camera. Yeah, the loading currently needs more time because basically each time he recreates the mesh. This, of course, could be optimized a little bit, but I think it's already a big step that we got so far to have this virtual lab. So you see the cameras, I suspect based on the angle, they are gonna be a little bit blocked. Wow, yeah, but not that much, right? So you see basically the blades. Of course, you could now iteratively get closer to what you would have if you try to are looking from the GOM system. Let's suppose you have 5 degrees and we have just 10 degrees field of view. Let's confirm that. And now you see we again would have from a much higher distance a view or like a picture of these two samples, right? And these samples, by the way, they are saved under the path, which is here called new save path, right? You can just click on the copy button and then you, well, let's actually do this right now. We can just look at this. I'm actually accessing things via TeamViewer, so give me a moment, please, to correct this. So we can now go into the, we can now go paste the path we have just copied by taking the image, right? And then we see the rendered image here as a PNG file. So you really see this. That's, of course, pretty nice. You can compare the two images which we have taken, right? So you see this three-dimensional change. So that's what we took. So I think this virtual lab is actually quite an interesting way to just, give a way to generate synthetic images of these kind of experiments that could be also do for other things like tensile test or whatsoever.